This video is for Design and Communication Graphics, PN 4025 for week 10. Now, the topics we're going to be dealing with this week is Platonic Solids, Archimedean Solids, and Projection of Solids, Inscribed and Circumscribed spheres. Now, for each of these topics, the level at which we need to know about them is quite minimal compared to some of the other topics that we teach. For the Platonic Solids, having an understanding of what defines a Platonic Solid, being able to name some Platonic Solids as well as identify how many Platonic Solids there are. The same for Archimedean Solids, being able to define, name and identify how many there are is as far as we really go. And also then for projection of solids, inscribed and circumscribed spheres, we're mainly going to be dealing with one object or one shape, which will be one of our Platonic solids. Actually, the first one that we deal with, which is a tetrahedron, which we've dealt with previously in this module before, and being able to draw an inscribed and circumscribed sphere in and outside of that shape itself. And for that, there'll just be a bit of a construction that you'll need to understand and be able to reproduce, as well as have an understanding for how to reproduce that depending on what information you have been given. So if we will look first of all at our Platonic solids, as you can see here we have a small bit of a definition, or what defines an actual Platonic solid itself in there in the bit of a text, as well as that identifying that there's 5 different Platonic solids, as well as giving you some key bits of information about the number of faces, vertices and things like that, and also identifying the names of them. You can see it's similar here with your Archimedean solids. You have your definition, or what defines an actual Archimedean solid, as well as that identifying the different names given to the different solids. Now, there tends to be a lot of them here. I wouldn't expect you to remember all these different names, as long as you have an understanding what an Archimedean solid is, and that it is a thing, and that if you need to find out more information at a later date, that you will be able to pull up that information and use that to, I suppose, solve any particular issues that you have. Now, as well as that, I've put in here a bit of a website that leads you to additional information on this topic if you'd like to do so. You'll find it's pretty easy to find information on any one of the topics that I'm going to talk about throughout this lab. Giving a quick Google search or even throwing into YouTube, there'll be plenty of videos and web pages breaking down this information. After that, when we're dealing with our projection of solids and inscribed and circumscribed spheres, we're going to be dealing here with really a tetrahedron and getting that inscribed and circumscribed sphere. As you can see there, there's a bit of a website that I've put in. That website actually brings you to a page where you get a diagram such as this one. This is actually a dynamic model, and by moving sliders you can actually change the shape of the size, the scale of that tetrahedron, and even rotate it in space itself. And then you'll be able to see how the actual centers and the spheres are changed depending on the shape of the tetrahedron itself. Now, there's an actual construction to complete an inscribed and circumscribed sphere for a tetrahedron, as you can see here on the right hand side and also see here on the left. Both of these are the same construction. One's just explaining using 3D imagery, as you can see below here in your 4 different steps, along with the piece of information that breaks them steps down. And along with that, then you have your normal orthographic views, which you'd be used to helping you break down the information of how to draw an inscribed and circumscribed sphere. Now, you will have to break down the information given here in both of these diagrams to understand how to complete that. I will leave that up to you to look at it and break down that information and then apply it to the drawing or the activities that we might have. I would suggest that you would draw a tetrahedron in elevation, plan and end view, and then try to do it before attempting the questions, just to get an understanding for the construction itself. See if your circle intersects the points at which they do within the drawing here, because as you can see, depending on the view that you're looking at it, like that circumscribed sphere itself does not touch off of the corners as the way that you look at it itself, but that's just because of the shape and how it sits within that sphere. As well as that, then I have a bit of an example and a bit of a demonstration going through how to complete a circumscribed and an inscribed sphere for a tetrahedron. In this example, I do it a bit differently than it's seen here. Well, not differently, but I use different views to find it, so that can then further help you develop your understanding for the construction itself. As well as that, I also have a picture of the finished solution, and you can see here. Now, I explain in the video itself that for my elevation, plan and end view, just because I didn't move them out far enough, you can see the spheres there overlap. For you, I would suggest just moving it that bit further out, just to ensure that they don't overlap, ensure that there's no confusion. As well as that, don't forget about the key bits of terminology that we might have used throughout the lab, like even identifying where the tetrahedron is, where the inscribed sphere, the circumscribed sphere. If you even want to break down the steps, if it helps you remember the construction that's involved, it is an important thing for you to know, and probably will end up on your final exam itself. Here's the first activity that you have. It will bring into play a lot of the stuff that we've covered throughout this semester's labs. It is a tough question. The actual solution to itself looks very similar to a one that you've previously completed, but the way in which this question is asked, it brings in a lot of elements that you have covered throughout previous labs and really tests your understanding of them principles at play to complete this question. Take your time at it. I have a small bit of a hint here video which breaks down a different question, let's say, that uses a similar construction that will help you complete this. Now, if you're feeling fairly confident, I would suggest you do this first of all without watching that video, and then if you're getting a bit confused, go back and watch the video that I give that bit of a hint, and that will hopefully then push you that last bit. It will definitely make you think. You won't just be rushing through this like normal. After that, then you have your second activity, which kind of develops from the first activity itself. So you're redrawing the previous tetrahedron. I say full in brackets here because I want that full tetrahedron, not the tetrahedron with the cut section through it. So the full tetrahedron, plan and elevation, and draw the inscribed and circumscribed sphere of the tetrahedron. This just brings into play your understanding of that construction that I talked about previously in the lab. That should be pretty simple. The first activity is really the one that's going to test you, but that's the level of activity that you will be getting in the exam. Then you just have your checklist like normal. Ensure that you have your first activity done, your second activity done, and have all elements submitted by the following Sunday, end of week 10. Now, again, there will be no principal sheet at the end of this week. This is also your last lab of the semester. Next week, I'll be providing you with sample questions, or questions that can help you then prepare yourself for week 12's final assessment. So what I'm hoping to do is put together similar questions that I'll be giving to you in that final assessment, handing them out to you within that week 11, and then giving you a chance, I suppose, to get ready and prepare yourself to answer this. We're not looking to catch anyone out. I'd be delighted to see everyone here have a good understanding for the topics and the principles that we have covered throughout the semester, so that then I'm confident in you to go out and teach a classroom of 24 students. Past that, like always, if you need extra help, you have my email. The 3 books here that I recommend for anyone struggling or having any issues. There's principles that are going to be used throughout this lab that will relate back to most of the topics that we previously covered.